Physical science learners and teachers, once again I greet in the name of the subject. Let's continue, and the topic for today is this: momentum and impulse. Very crucial, and the knowledge that is supposed to come with in the previous grade, as this one is a grade 12 topic. In grade 10, you should have learned about vectors, motion in one dimension, instantaneous velocities and graphs of motion. And then in grade 11, you should have learned about Newton's laws and applications thereof, because also in this we'll talk about the same language of vectors and Newton's laws. Now, first, as per examination guideline, we are now told from the definition of our momentum. In this case, we'll deal with momentum, and impulse will follow later. So what is momentum? Momentum is defined in this case as a product of an object as velocity, mass in this case, mass and velocity. So you should be knowing the velocity. Remember, mass is measured in kilogram in the lower grade that you learned units. Velocity is measured in meters per second. And this velocity, once again, in grade 10, we learned that velocity is a vector. Therefore, from this definition, the symbol for momentum is P. Then, in that now, according to the definition now, momentum, which is P, will be the same as mv. So it's the product of mass of an object and its velocity. Now, because mass is measured in kilogram and velocity in meters per second, therefore the unit for momentum will be kilogram meters per second. But again, we know that momentum is a vector. Therefore, if momentum is a vector, what makes it momentum to be a vector? Very important. Momentum is a vector quantity. Now, what makes the vector quantity is that from the P equals to mv. Because mass is a scalar, it's always positive, and v can be positive or negative because a vector. Remember, a negative vector is a vector in opposite direction. Therefore, it means that now the product of this scalar and vector can give us a vector. That's why momentum is a vector. So what makes momentum a vector is because of the velocity in this case. That's what makes. So every time when you calculate momentum, know that the final unit will be kilogram meters per second plus the direction. Very important, direction. So you must say the direction there. Even if you are not requested, I think it's safe to have direction all the time. So now, can we calculate momentum using the definition? Yes, because momentum, in this case, before calculations, let's talk about the two graphs in momentum. Graphs in momentum, I've got two. One will be momentum being directly proportional to the mass. Therefore, the graph will be this shape. Direct proportion must pass through the origin, momentum, mass. That will be the shape of the graph. Or again, we know that momentum is also directly proportional to velocity. Therefore, if you have to draw momentum velocity graph, will be momentum velocity will also be directly proportional. I mean that now if you double the mass, you are doubling momentum. If you double the velocity, also the momentum will be doubled. That's the relationship about this. Now, in terms of calculations, as we are looking at this example, let's take an example, very easy one. in this case a worked example, just to take it through. A simple one will say a blue whale, maybe if we have got a blue whale of 150 kilo, a blue whale of 150 kilogram, and then now it's moving at 2 meters per second. 2 meters per second. Let's just say east. And now they say calculate the momentum of the blue whale. Blue whale is of 150 kilogram, moving at 2 meters per second east. Find the momentum. The momentum of the blue whale. Momentum. Now what do we do? In all the times when we calculate momentum, let's start with the formula. The formula is P equals to mv. That's the first part. From there now we substitute what is the mass is 150, and then the velocity is 2 in this case. Then the answer will be 300 kilogram meters per second. Don't forget, momentum is a vector. It becomes now east. That is how we calculate the momentum. The next example will be, let's talk about the football field. A soccer player, in this case, where now they are playing with the soccer ball. If a soccer ball has a momentum of in this case 8.4 kilogram meters per second after being kicked. Now they say if mass of the soccer ball is 0.42 kilogram. Now they say find the velocity. Find the velocity with which the ball was kicked. So it's not always that you'll be calculating momentum. You can be given a momentum and then they ask you to calculate the velocity as well. So what do? We first write the formula, P equals to mv. Then from there now we substitute. Remember, the momentum of the soccer ball is 8.4. Then the mass of the ball is given as well is 0.42 multiplied by the velocity. Now the unknown here is velocity. Then now we use a calculator. Then if you use a calculator, we are going to find that it means that the velocity with which the ball was kicked using a calculator, then it will be 20 meters per second. In this case, in the direction of motion, if the direction is not given, direction of motion in this case. That's how we deal with the concept of momentum. So in the next part, we'll deal with how, when the momentum changes, how do we calculate the change in momentum. Very important. How do we calculate the change in momentum when the momentum changes? Therefore, we'll entertain the issue of our change in momentum. Which is your delta P. So we know that delta will be about the final minus initial. So very important, final momentum final momentum minus the initial momentum. So we'll talk about that. So until then, thanks.